to the 5th grade. This is our last grade level that we're going to go through standards with in Math 277. In 278, we cover grades 6 through 8 standards, so we definitely get more intense. So we're going to do this week is operations in algebraic thinking along with number and operations in base 10. So here we have a few operations and algebraic thinking. So we're going to actually start doing quote-unquote algebra. Even though you've probably picked up that we've been doing it all along, we just haven't called it that. Grace says that 4 times 6 plus 2 is 26, but Lupita says that 4 times 6 plus 2 is 32. How do you think each student calculated the equation? So we have Grace and Lupita, the same equation, different solution. Looking at Grace, it appears that she multiplied 4 times 6 first, which is 24, and then added 2 to get 26. However, Lupita looks like she added 6 and 2 first, so 6 plus 2 is 8, and then multiplied that by 4 to get 32. We need the order of operations at this point. How do we know which one is correct? And we need to keep some consistency. So we need to do parentheses first, then exponents, which I know we haven't gotten to yet. We'll get to them in 278. And we need multiplication and division working left to right, and then addition and subtraction working left to right. So use the order of operation to determine who correctly simplified the expression from the previous slide. We need to do multiplication before addition. 4 times 6 is 24. Adding to 2 gives us 26. Helen wants to make her own snack mix. Here are the items that she purchased. 1 scoop of chocolate chip costs $3. 2 scoops of dry banana chips cost $5 for each scoop. 1 scoop of peanuts for $3. 3 scoops of raisins cost $2 for each scoop. Write an expression to show the amount of money that Helen spent on her mix. If needed, draw a model to represent the snack mix. Pause the video and see if you can put together the correct expression. We should have 3 plus 2 times $5 for 2 scoops of dried bananas, plus $3 plus 3 times $2, so 3 scoops of $2 of raisins. It may be easiest to group them together so we can kind of see the 4 different pieces of the different pieces of the snack mix. So then we can multiply first. So 2 times $5 is $10, and 3 times $2 is $6. Adding them all up, her snack mix costs $23. An expression is like a recipe that lists mathematical calculations and has a specific order in which it must be evaluated. A specific value can be calculated by a variety of equivalent expressions that show the steps taken to evaluate them. Oliver has 4 pencils and 10 markers. Helen has 6 times as many as Oliver. How many does Helen have? Well, we know that Oliver has 4 pencils and 10 markers, so altogether he has 14 pieces. But Helen has 6 times as many as Oliver. So whatever Oliver has times 6. Well, 4 plus 10 is 14, and 6 times 14 is 84. So Helen has 84 pieces. Mr. Fun had 24 notebooks that he sorted into 8 equal groups. He then realized he needed to triple that amount for each group. How many total notebooks did each group need? We started with 24 and we divided it into 8 groups, but then he realized he needed to triple that amount. So we need to take whatever that result is by 3. And according to the order of operations, we work multiplication and division left to right. So 24 divided by 8 is 3, and 3 times 3 gives us 9. So each group had 9 notebooks. Evaluate 1/2 times 956 minus 22 times 41. Within parentheses, we need to do the multiplication first. So 22 times 41, envisioning that area model that we did in 4th grade, we would have 4 pieces since we have a double digit times a double digit. And the 4 different areas would be 20 times 40 plus 20 times 1 plus 40 times 2 plus 2 times 1. So altogether, we would have 902. Now we still need to work on things inside our parentheses. So we need to take 956 and subtract 902, giving us 54. Finally, we need half of 54, which is 27. An expression has a specific order in which it must be evaluated. The order of operations provides consistency when we evaluate expressions with more than one operation. We use grouping symbols to represent different mathematical situations. These sometimes change the value of the expressions and sometimes they do not. Is this equation true or false? 4 times 7 plus 8 is 60. This equation is false. Let's add parentheses to make it a true statement. Let's see what happens when I group our first two numbers together. 4 times 8 and then add 4 times 7 and then add 8. Well, 4 times 7 is 28, and when I add 8 to that, we get 36. That does not equal 60. So let's try grouping a different way. 4 times 7 plus 8. Well, when we're in parentheses, we have to do those first before multiplication. So 7 plus 8 is 15. When I multiply that by 4, we get 60. So we found the correct solution by adding in parentheses. Where can we add parentheses in the equation to make it true? Pause the video and see if you can't figure it out. Let's start grouping the first two together. 8 plus 26 is 34. Multiplied by 6 minus 2 gives me 204 minus 2, which is 202. Nope, that doesn't work, so let's regroup a little bit differently. Let's group the 6 minus the 2 first, which would be 4. And then multiplication comes next, so 26 times 4 is 104. Adding 8 to that gives us 112, which is the solution that we needed. Below is a picture that represents 9 plus 2. So I have 9 light gray and 2 dark gray for a total of 11 altogether. Let's draw a picture that represents 4 times 9 plus 2. Well, if this is 1, we would need 4 rows of 9 plus 2 to get our correct solution. So then how many times bigger is the value of 4 times the quantity of 9 plus 2 rather than just 9 plus 2? Well, the value is 4 times as big because we can see that there were 4 equal rows above of 9 plus 2. Further, 9 plus 2 we know is 11, and 4 times 11 is 44, which is 4 times as many. Fill in the blanks given the following situation, given the following expression. 4 times the quantity 25 plus 16. Allie bought candy to hand out at the fall festival. Each bag had more pieces of hard candy. Each bag contained blank pieces of hard candy and blank pieces of chewy candy. She bought blank bags of candy. How many pieces of candy did she have? Well, looking at the objects inside the parentheses, those must be the types of candy I have. I have 25 and 16. We know that there are more pieces of hard candy than chewy candy. Therefore, the larger number of 25 must be the hard candy, and the smaller number of 16 must be the chewy candy. All in all, she bought 4 bags of candy. How many pieces did she have? Well, 25 plus 16 is 31. Multiply that by how many bags we have of 4, and that equals 124 pieces of candy. Numbers and operations in base 10. We have 7 different standards that we have to cover. Which number has a smaller value of the digit 6? Prove your answer using a visual model. 5 and 36 hundredths or 7 and 6 tenths. Let's use base 10 models. A flat represents a whole piece, a long represents the tenths, and a unit represents hundredths. So if I have 5 and 36 hundredths and then 6, 7, and 6 tenths, 6 hundredths would be 6 little unit pieces, whereas 6 tenths would be 6 longs. I can visually see that the digit of 6 in 5.36 is the smaller value. Which number has the larger value of the digit 1? Prove your answer using a visual model. 1 and 2 tenths or 19 hundredths. I have the value of 1 in 1 and 2 tenths as a whole, which is just a box for short instead of putting all the little tiny squares. And 1 is in the value of the tenth spot, which would represent a single long or 10 little ones put together. I can see that a whole is much larger than a long. So the digit of 1 in 1 and 2 tenths has the larger value. When the place value extends to the thousands, the structure does not change. We can record a decimal number as the sum of the value of its digits. Write 0.342, so 342, in the expanded notation. This is said as 342 thousandths. Viewing this number in the place value chart, 3 is in the tenths location, 4 is in the hundredths, and 2 is in the thousandths. So 3 can be represented as 3 tenths plus 4 hundredths plus 2 thousandths. And if I were to add all of these fractions together, we will get 342 thousandths. We can extend this into the units by taking 3 copies of 1 tenth plus 4 copies of 1 100th plus 2 copies of 1 1,000th. We can also show the value of each digit within 342 thousandths using fractions that shows the powers of 10. So notice on the 100 it's the same as 10 times 10, and 1,000 is the same as 10 times 10 times 10. Let's continue with 7 and 401 thousandths written in expanded notation. So this is 7 and 401 thousandths. When I look at it in the place value chart, I see I have 7 ones, 4 tenths, 0 hundredths, and 1 thousandths. So 7 times 1 plus 4 copies of 1 tenth plus 1 copy of 1 1,000th. Notice I don't have any hundredths, so I can leave that portion blank. Which is greater, 1 tenth or 1 hundredth? Show the comparison on the number line. Well, 1 tenth is located where the arrow goes to, but 1 hundredth is 10 times smaller, so it goes just after the 0. So therefore, 1 tenth is greater than 1 hundredth. Which is greater, 2 tenths or 3 hundredths? I can point my arrow at exactly where 2 tenths is, and 3 hundredths is much smaller. So therefore, 2 tenths is greater than 3 hundredths. We can relate the dividend, divisor, and quotient in a division problem to parts of an array model. Michael makes $55 in tips every week as a waiter at Paradiso's restaurant. How many weeks will it take him to earn the $330 he needs to buy a new smartphone? 330 divided by 55 is how many? So how many groups of 55 can we make? Let's use our base 10 pieces. To know how many groups of 55 I can make. 3, 4, 5. 1, 2, 3, 4, 5. Sorry, I didn't grab a big enough one here. 1, 2, 3, 4, 5. 1, 2, 3, 4. So we're only at 165. We have to keep going to see how many we will get, how many weeks it will take us. There we go. We've reached 330. So it looks like I did 1, 2, 3, 4, 5, 6 groups to reach the $1,000. Therefore, it would take 6 weeks to reach $330. A very generous customer comes into Pa's restaurant and leaves a $125 tip. He asks Zeus to split the tip with the other 4 waitresses that are working. How much money should each waitress get? Show using base 10 pieces. Now be careful, a common mistake is they see the word 4 and they automatically divide 125 by 4. This is for Zeus and 4 friends, so there would be 5 of them, right? So if you were to use base 10 pieces, you would notice or see that each person would get $25 part of their tip. You and some friends want to go on a camping trip. Here are the details. 195 students, 1 chaperone for every 7 students, a maximum of 16 people per van, $5 per student, and $8 per adult. We need to know how many chaperones are needed, how many vans are needed, and how much does the trip cost. So we're going to break it down here little by little. We know that the relationship between multiplication and division can help us solve problems. So let's apply that reasoning here. I know that there are 195 students and that there is 1 chaperone for every 7 students. So we're going to use the partial quotients to help us divide. I know that 7 times 20 is 140. If I did 7 times 30, that would be too many. So when I subtract, we get 55. I also know that 7 times 7 is 49 with a remainder of 6. So to find the entire result, we add the pieces that we multiplied by 7 with to get 27. However, there are still 6 kids that won't have a chaperone. So therefore, we would need 28 chaperones in order to have all of our students covered. How many vans are needed? Well, we know that there are a maximum of 16 people per van. We have 195 students. We just figured out that we have 28 chaperones. So we know we have 223 people altogether. Again, we're going to use partial quotients to help us decide how many vans we need. 223 people divided by 16 people to a van. 16 times 10 is 160. Remainder of 63. 6 times 3 is 48 with the remainder of 15. I add 10 and 3 together to get 13, but there's still 15 people that don't have a van. Therefore, we need 14 vans to cover all of our people. How much does the trip cost? We know that it's $5 a student and $8 for an adult. We have 195 students and 28 chaperones. So 195 students times $5 is $975. 28 chaperones times $8 is $224. The total cost, adding them together, the total cost would be $1,199. We know that when we multiply whole numbers, the factors determine the size of the product. Greater factors produce larger products, and smaller factors produce smaller products. I wonder what happens to the product when our factors are decimals. So what happens when we multiply by decimals? Gwen cycles 3.3 miles each day for 5 days. Multiplying with the decimals can be tricky, so it's always a good idea to estimate first. If we were to round 3.3 down to 3, our estimate would be 3 miles times 5 days for 15. If we rounded up to 4, we would estimate 4 miles times 5 days for 20 miles. So our answer should be somewhere between 15 and 17. Excuse me, 15 and 20. Here is a base 10 representation. 3.3 can be represented as 3 wholes, so 3 flats, and 3 tenths. So we would highlight 3 of them. However, we did this amount for 5 days. So we would have to extend the 3 by the 5 as well as the 3 tenths by 5 to create an array, a perfect rectangle. Notice that this is set up just like when we did array models with whole number multiplication back in 4th grade. So the same ideas, the same models can be used over and over again as we filter through the different grade levels. Even when we get to Math 278, you'll see that when we reach algebra tiles, when we want to FOIL or use the distributive property. So along the top, we'll have 3 plus 3 tenths. So I break them down into the whole. On the left, 5. 5 times 15 and 5 times 3 tenths is 1.5. If I were to add 3 of those tenths together by 5, we would have a whole, we would make one whole, and we would have 5 tenths or half of a square left over. Adding our pieces together using a little bit of mental math, we get 16.5 miles. We can see that when one of the factors is a decimal number that is smaller than 1, the product of the two factors is smaller than the whole number factor.